adding waves. Now, when we add waves, it's actually called superposition. All right, so this is adding sine waves in particular. When we talk about longitudinal waves, the process works similarly, but it's really hard to graph and do mathematically. So this picture here shows the blue wave traveling from left to right and the red wave traveling from right to left. So when you have two waves that interact in the same medium, they actually just pass right through each other. All right, that transmission of energy continues until it gets to a boundary, like we talked about in the previous part of the lesson. So when we have these two waves, you take the position of one and you add it to the other. And you can see here, it obviously changes with time. And you get this black wave, which is the combination of the two. Now, in this case, super just means added, right? So you take one and then you add some extra. But what if the other wave's negative? Well, then you subtract it. So I can't really pause this animation, but if you watch when the peaks of the two waves, the red and the blue one, overlap, you'll notice the black wave hits its maximum there, and that's the position of an antinode. When the two waves, red and blue, are crossing and the peaks are the most offset, all right, so when their two equilibrium points pass through each other, the antinode is actually also passing through the equilibrium position. So hopefully by playing with the couple of simulations that I pointed you towards, you notice this pattern. Okay, we'll practice this more in class, but this is what superposition is all about. So when the two waves interact, all right, you can get what's called interference, all right? And so you have two types. You have constructive interference and destructive interference. And we saw both examples in the previous slide. All right, here, constructive interference, all right, is those moments when the peaks of the waves and the troughs of the waves were aligned. So this is what we call in phase, okay? In this case, you have two identical waves, those are the two on the bottom, and they add together to make a bigger wave. So if it becomes bigger, it's constructive interference, all right? On the right-hand side, you have two identical waves, but completely offset. So where one is at a crest, the other's at a trough, all right? And therefore, every little bit above is canceled by the little bit below in the other wave. And so you get completely destructive interference. And if you actually have these two waves, you'd actually see a completely flat line. So it doesn't have to be completely destructive, but these are the two extreme examples.